Welcome to the Rich Report, a podcast with news and information on the world of high-performance computing. Today, my guest is from PGI/Nvidia. We have Doug Miles. How you doing, Doug?
Good. How are you, Rich?
Great. Great to have you on the show once again. What I thought we'd do, Doug, is maybe go through your deck here, learn about what PGI is announcing, and then we'll do a Q&A at the end.
That sounds good. Okay, so I will get started. We're going to talk about PGI 2014 today, which is the latest release of the PGI compilers and tools. We're going to start out just by talking about the general features of the PGI 2014 release. PGI is part of Nvidia now since last summer, but our mission continues to be delivering Fortran C and C++ compilers optimized for complete HPC systems, which means we're continuing to aggressively develop optimizations and language features for multi-core x64 CPUs as well as accelerators. And the key new features in PGI 2014 for multi-core include some performance improvements. Our OpenMP performance is almost 10% improved over the first release of PGI 2013 and is now about 80% faster than the GCC compilers on Intel Sandy Bridge. We've added incremental Fortran 2008 language features, and we'll have full C++ 11 in an update release later this year. We have comprehensive MPI support and have updated all of the MPI features in the PGI compiler. So the latest versions of MPI-CH, MVAPICH, OpenMPI, SGI MPI, and Microsoft MPI in Windows are all supported. PGI's debugger and profiler are both OpenMP and MPI enabled. And while they are not intended to scale to thousands of processes like DDT and TotalView, we ship them with every version of the PGI compilers. They're always there, so you can quickly bring up an OpenMP or MPI debugging session on any system that PGI supports, whether it's Linux or Mac OS or Windows. And another great feature that has been added is a free version of the PGI compilers for MacBooks. So this includes Fortran 2003 and C compilers with full OpenMP 3.1 and a version of the PGI debugger that's available for free download, which we hope will be useful for a lot of people. And to drill into the performance features a little bit, I mentioned SpecOMP, and this is a chart that shows the comparative performance of the GCC 4.8 compilers to Intel 14 to the PGI 14.1 release. And the blue bars there indicate performance on an Intel Sandy Bridge, 16 cores, 2 sockets. The green bars are performance on an AMD pile driver with 2 sockets and 32 cores. So normalized to GCC, you can see that both Intel and PGI are on the order of 80% faster than GCC on Sandy Bridge, and a little less of a premium on pile driver, with PGI a little faster on that platform. And this slide makes it really clear that if you use OpenMP extensively and you're relying on GCC exclusively rather than installing one or more of the commercial compilers, you're essentially disabling 40% of your cluster nodes for a good percentage of your applications, which is not a good idea if you spend $1 million or more for a cluster. And that's why big sites like Oak Ridge and most of the Cray sites keep several different compilers installed and up to date on their systems. Compilers don't cost much in the grand scheme of things, and it's the best way to ensure you're getting as much performance as possible across all of your applications and workloads. In addition to the CPU features, we've added a lot of new accelerator features. We now support both Nvidia and AMD GPUs with CUDA Fortran for Tesla GPUs and OpenACC Fortran C and C++ across both Tesla and AMD Radeon GPUs. And this allows users for the first time to compile and run the same OpenACC source code across either an Nvidia or an AMD GPU. And while it's not too visible to end users, I should point out that we've moved to native code generation on both types of GPUs. So we're integrated with NVIDIA's NVVM code generator on NVIDIA Tesla GPUs at the intermediate language level, and we've done that same sort of integration with the AMD Radeon code generator on AMD GPUs. We've added several of the important OpenACC 2.0 features and some related optimizations that I'll talk about here in a minute. And we're really pushing on tool support to make it easier to migrate and debug applications in CUDA Fortran and OpenACC, and I'll talk more about that in a minute here too. I want to show you a performance chart here, which is based on, the question is OpenACC really performance portable? We get that question all of the time, and by that I mean, can you write one program and have it compile and execute correctly and with good performance across different types of accelerator targets? And the Systems Performance Evaluation Corporation, the people that bring you the spec CPU and spec OMP benchmarks, in March of this year will release a set of benchmarks to measure the performance of accelerators using OpenACC. And those results aren't available yet, but using some benchmarks that were candidates to include in that set, this chart shows the relative performance of 16 different codes, identical OpenACC running on one core of a Sandy Bridge versus a Tesla GPU versus an AMD Radeon GPU. And I need to emphasize these are not spec results. The benchmarks are not finalized. They'll be out soon, but it includes the Cloverleaf Mini application from AWE, the Ghost Mini application from Oak Ridge, and 14 other codes. And if you compile and run all 16 of them and average the performance across all of the codes, you'll see that the GPUs average about 15 times faster than one core, which means that even with good scaling of a parallel version on the host CPU, the GPUs are on the order of 2x to 3x faster than a Sandy Bridge socket. And this is the identical source code running across both the Nvidia and AMD GPUs, which have very, very different microarchitectures. And that is performance portability, and that's what we really want out of a programming model. And we can see here that OpenACC is delivering that across Nvidia and AMD GPUs. And you might ask, well, which GPU is which? And I didn't tell you that, and it's not my job to sell you one or the other. We're just trying to deliver the best performance we can out of each of these targets. Some of the other new features, OpenACC 2.0 added procedure calls, which is a really important feature. In OpenACC 1.0, all of the procedures or functions in a piece of code to be offloaded had to be inlined by the compiler. And the routine directive in OpenACC 2.0 enables you to make procedure calls in an accelerator region. It's a big step forward, which should significantly increase the number and types of applications that can be ported to OpenACC. OpenACC 2.0 also includes unstructured data lifetimes, which is or unstructured data regions, which allows you to allocate accelerator memory and move data between CPU memory and GPU memory at arbitrary points in your program. And together with the update directive, this gives you a really fine-grained control over data movement and optimization. This is not an OpenACC 2.0 feature, but there is a feature called host data in OpenACC that among other things, enables support for GPU direct communications from within an OpenACC program from accelerator memory to accelerator memory between nodes, and we've really beefed up support for that in PGI 2014. And there's a lot of other OpenACC 2.0 features, new API calls, improved interoperability with libraries and CUDA or OpenCL, support for multiple device types, lots of features coming, and several of these are in PGI 14.1, will be OpenACC 2.0 feature complete around the middle of this year. This is a screenshot of Alinea DDT, and again, one of the features we've added in the compilers is support for third-party debugging tools, and this is just a screenshot of DDT debugging a CUDA Fortran program, and you can see you can set a breakpoint in a kernel, stop, examine data, see where you are in the CUDA grid and thread block geometry, examine data, all the things you would expect to be able to do in a debugger. And in PGI 14.4, this capability will be expanded to support OpenACC programs as well. So we're really excited about that. A big step forward in tools capability. So just to summarize the key features, multi-core x86 performance improvements, as shown by SpecOMP results, OpenACC on both Nvidia Tesla and AMD Radeon GPUs. We think that's really important to let people run OpenACC codes on any type of accelerator they want to target. OpenACC 2.0 features and optimizations, we're pushing hard on those to deliver full OpenACC 2.0 in the first few months of this year. Tools, which you'll see a big push on tools throughout the year to enable debugging and profiling of OpenACC. And then last but certainly not least, the ability to use PGI compilers on MacBooks at no cost with full OpenMP capability and a debugger. So that's a summary of the benefits, and I'm happy to answer any questions you might have.
Well, thanks for that, Doug. You know, the most recent point you made there is interesting to me. I own one of these fancy new MacBooks. So you're saying that I can get access to that programming environment, that GPU that's right here in my laptop, using the PGI?
So today, the free version is CPU only.
Okay.
And so you can do OpenMP and multi-core programming on the CPU. The GPU version is still in the paid version of PGI.
I gotcha. Okay. And Doug, I was going to mention, you know, I was at SC13, I was in a kind of a group discussion about compilers and tools, and someone asked, well, what's the best compiler for x86 for these clusters? And somebody else piped up, well, you'd have to get that from Nvidia. And they thought it was all funny, but would you agree with that? And do you think, if so, do you think that will continue to be the case?
Well, so you know, I'm biased, obviously, but I think the real objective answer is that you know, if you want to get the most out of your application, you probably need to try a couple of different compilers, and we are the best compiler for a lot of different applications. I'm not going to say we're the best compiler for every application, but as I said earlier, the larger sites usually keep multiple compilers installed, and you know, to answer your question more directly, our mission here is HPC system compilers, and x86 processors are a key component of HPC systems. So we'll continue to push aggressively on x86 features and capabilities as we push forward on accelerator capability. And really the only thing that has changed here since we have become part of NVIDIA is we've become very much more focused, and I should say refocused, on high-performance computing. We were working both in HPC and mobile and embedded previously, and NVIDIA has really focused us on high-performance computing. So I think people will see a lot of benefit from that here in the coming year or two.
Well, terrific, Doug. Well, hey, I found this very interesting, and I want to thank you for coming on the show today.
Yeah, thanks for having me, Rich.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.